Hello, my name is AIZUDDIN, and today I will introduce you to the reader-writer's problem of chat. Before we dive into the topic, let me introduce our team member, which consists of me, AIZUDDIN bin ASMAN, and FERNADO George, and HERYANSHAH. Okay, now let's move on into the next slide. Okay, the reader-writer's problem is a concurrency problem faced when a shared resource that is not thread-safe can be read and written by multiple threads at the same time. The problem happens when one thread is reading or writing and another thread write at the same time. The key requirement of the reader-writer's problem are multiple readers can read concurrently. This ensures efficient use of resources as reading is generally a non-intrusive operation that doesn't alter data. Only one writer can write at a time. This prevents data corruption by ensuring that no other operation interferes with the writing process. No reader while a writer is writing. This prevents readers from accessing inconsistent and or partially written data. Okay, the no writer while readers are reading. This ensures that the data being read remains consistent and is not altered during the read operation. The importance in concurrent programming is managing access to shared resources is important in concurrent programming to prevent data races and ensure data consistency. If multiple processes attempt to read and write simultaneously without proper synchronization, it can lead to unpredictable results and data corruption. The reader-writer's problem illustrates the needs for synchronization mechanisms such as mutex lock and semaphore to control access to shared resources and maintain system integrity.
Okay, alright guys, today we're gonna talk about this thing called the reader-writer's problem in programming. So it's a classic problem that deals with how to manage a shared resource like a database or a file that can be accessed by two types of people, that is readers and writers. Okay, we're gonna use some special tool called mutex locks and semaphores. Okay, so what is this? What is this mutex locks and semaphores? So, okay, the first of one that I will explain is read count. So what is read count? So read count, this thing is will tell us about how many readers are currently using the shared resource. Okay, that is read counts. Okay, the next one is mutex, mutx. Okay, so this is a lock that we use to protect the read count variable. Okay, the next one is rw mutex. So what is rw mutex? Okay, this is another lock that we use to control access to the shared resources for writers. Okay, the next one is retry, readtry. Okay, this is a semaphore that we use to make sure no new readers can get in while a writer is waiting to write. Right. Okay, so I will explain one by one. There are four aspects I want to explain. The first one is multiple readers can read at the same time. So okay, when a reader wants to use the shared resource, they first grab the mutex lock to increase the read count. Okay, if read count was 0, which means no one reader is reading, the reader also grabs the rw mutex lock to make sure they have exclusive access. Okay, when the reader is done, they decrease the read count variable and release the rw mutex lock if read count is now 0. I will explain the next one, that is, okay, number 2, only one writer can write at a time. So when a writer wants to use the shared resource, they grab the rw mutex. Okay, rw mutex lock to make sure they have exclusive access. The writer can only get the rw mutex lock if there are no other reader or writers using the resource. Okay, three is no readers while a writer is reading. Okay, the retry, readtry semaphore is used to make sure no new readers can get in while a writer is waiting to write. Okay, when a writer wants to use the resource, they first grab the retry semaphore, which will block any new readers from getting the RW mutex log. Okay, the last one is okay. No writers while readers are reading. Okay. For this thing, the RW mutex logs ensures that only one writer can use the shared resource at a time, and it also blocks writers from accessing the resource while readers are reading. Okay, by using this combination of looks and semaphores, sorry. By using this combination of locks and semaphores, we can make sure we meet all the requirements of the reader writer's problem and keep everything running smoothly. So this is the solution for that common problem. Thank you.
Okay, for the code walkthrough, we're gonna go through the code. There's 4 key functions, which is write, read, increment read count, and decrement read count. Okay, for the first one, which is write, uh, for the mutex log, which is wait mutex, is used to acquire the mutex log to check the writer writing flag and read count safely. The check writer status. If the writer writing is true or read count is greater than 0, it means either a writer is currently writing or reader are reading, so writing is not allowed. The function prints a message and exit, releasing the mutex log. If there is no writer is writing and no reader are reading, writer writing is set to true, indicating that writing is in progress. The write mutex log is acquired to ensure exclusive access to the shared source. The mutex log is released with signal mutex, allowing other thread to proceed. A message is printed to indicate writing is allowed, and the writer waits for user input to simulate the writing operation. After writing, writer writing is set to false, and the write mutex log is released with signal write mutex. A message after that is printed to indicate that the writer has finished. Okay, for the read, a wait mutex is used to acquire the mutex log to check the writer writing flag safely. And then if writer writing is true, it means writer is currently writing, so reading is not allowed. The function prints a message and exits, releasing the mutex log. If there is no writer is writing, the mutex log is released with signal mutex, and increment read count is called to safely increment the read count. A message is printed to indicate reading is allowed, showing the current read count. And then the reader waits for user input to simulate the reading operation. After reading, decrement read count is called to safely decrement the read count. A message is printed to indicate that the reader has finished showing the updated read count. Okay, for the increment read count coding, the read count is to keep track of the number of readers currently accessing the shared resource, and then the wait mutex is used to acquire the mutex log, ensuring that only read count is allowed. And then the increment read count is incremented safely within the critical section. If you are the first reader, the read count will be 1, indicating the first reader. The write mutex log is acquired to block writers, ensuring that no writer can write while the readers are reading. And then after that, the mutex log is released with signal mutex, allowing other threads to proceed. Okay, for the decrement read count code, as similar to increment read count coding, the read count keeps track of the number of readers currently accessing the shared resource. And then the mutex log is used so that it will ensure only the read count variable will able to access. And then the decrement read count will be used. Okay, to indicate the last reader, the read count will display 0, allowing writers to proceed. And then release lock will be used. The mutex lock is released with signal mutex, allowing other threads to proceed. Okay, let's go through the two key function which is used to acquire and release lock. It is used in the previous code. It is consists of wait and signal. Okay, let's go through the first part, which is wait. The function purpose is the wait function is designed to acquire a lock, ensuring that the thread executing this function gains exclusive access to the critical section of the code. The function takes a single parameter, lock, which is an instance of a lock object. The function first check if the lock is not none, which is valid lock object is provided. If a valid lock is provided, the lock acquire method is called. The method blocks the calling thread until it can acquire the lock. Okay, once the lock is acquired, the thread has exclusive access to the critical section, preventing other threads from entering this section until the lock is released. Okay, let's go through the signal part. Okay, we can look the code here. The signal function is designed to release a lock, allowing the threads to acquire it and access the critical section. This function takes a single parameter, lock, which is an instance of a lock object. Okay, how does the lock release work? Firstly, it will do a condition check, which is the function first check if the lock is not none, and then it will apply the release method. If a valid lock is provided, the lock release method is called. This method releases the lock, allowing other threads that are waiting for the lock to proceed. And then after that, synchronization control. Releasing the lock ensure that other thread can now acquire it and enter the critical section, maintaining proper synchronization and preventing rest condition. Okay. How does synchronization points prevent rest condition? Okay, first of all, wait mutex and signal mutex in increment read count and decrement read count code. It offers protection of read count by acquiring and releasing the mutex lock around operation that modify read count. We ensure that only one thread can modify read count at a time, preventing rest condition. This atomic access guarantee that increment and decrement are performed correctly without interference from other threads. And then after that, the wait, which is write mutex, and signal write mutex. It will perform a mutual exclusion for writers by acquiring the write mutex lock when a writer wants to write. We ensure that no other writers or readers can access the shared resource simultaneously. This prevents rest condition between readers and writers and ensure data consistency. Okay, after that, the wait mutex and signal mutex in read and write. It will then checking the condition safely, acquiring that the mutex log before checking condition, such as writer writing or read count, is bigger than 0. Ensure that these checks are done in safe, synchronized manner. Then this will prevent multiple threads from simultaneously checking and modifying the condition, which could lead into inconsistent state. The conclusion is by using this synchronization mechanism, our solution effectively manage access to the shared resource, ensuring that the readers and writers operate without conflicts. This will prevent race collision and maintains data consistency and integrity in concurrent environment. Move on to the next slide.
Good morning, good afternoon, good evening, or good night, whenever you see this video. So I will continue with the test scenarios that we did in this lab project. Okay, so test case 1. A writer is writing and a reader attempts to read. In this case, we have a writer who is already waiting to a file. Okay, already. Then a reader comes along and tries to read from the file. This is the same file. So a writer is writing and then a reader tries to read the same file. Since the writer has exclusive access, the reader is not allowed to read and has to wait until the writer is finished. Okay, let's dive deep into the code given. So we got two nested functions in this test case writer reading function. So the first one is writer, which call the write function and then sleep for 1 second. It means the writer writing for 1 second. And then we got the reader function. We call the sleep for 0.1 second and then calls the function. Sleep for what 0.1 second here means only waits for 0.1 second. And two threads are created using threading.thread, which is the writer thread and the reader thread. So this thread is used to run this writer and reader function simultaneously. So we use by using the start method, and then we use the join to wait until both of them to complete before the function returns. So why the and let's see at the output there. Writing allowed, write text on. Press enter to finish writing. Reading not allowed, writer is writing. Why reading is not allowed? Let's look back into the code. The writer writes for 1 second, and then the reader needs to wait only for 0.1 second. It's like the reader is disturbing the writer to write. So hence reading is not allowed. Let's continue with test case number 2. No writer is writing and a reader attempts to read. So here, there is no writer currently writing to the file. However, when the reader tries to read, the system checks if the writer is waiting to write. If so, reader is not allowed to read and has to wait. So if what this means is the writer is not right to the file right, but if the writer wait to write, hence the reader also not allowed to read. So let's see deep dive into the code. So we got reader function that will call the read function and then sleep for 1 second. And we also have reader thread and start and join method. So let's see here, which is reading not allowed, writer is writing. Okay. So why reading is not allowed, writer is writing? It's just like what I mentioned before. It is because the system check if writer is waiting to write. Since the test case for no writer is writing and writer attempts to read has not been executed yet, the system still thinks a writer is waiting to write. Therefore, the reader is not allowed to read. Next, test case number 3. No writer is writing and no reader is reading, but a writer attempts to write. In this scenario, there are no reader or writer currently accessing the file. When a writer tries to write, the system checks if any readers are reading or if another writer is waiting to write. If either of these conditions is true, the writer is not allowed to write and has to wait. Okay, it means that if there are any reader or is reading, or if there any writer is waiting to write, so the writer is not allowed to write. So let's see the code. So we got a writer function here, which we'll call the write function and then select for 1 second. And then we got the thread and start and join method, same as before. So let's see the output. So here, writing, writing not allowed. Writer is writing or reader are reading. So this is because the system will check, as I mentioned before, if any reader are reading or if a writer is already writing. Since no one is currently accessing the resources, the system still thinks a writer is waiting to write, and therefore the new writer is not allowed to write. Let's case number 4. A writer is writing and another writer attempts to write. Imagine two writers, writer 1 and writer 2. Writer 1 is already writing to the file. When writer 2 tries to write, the system checks if a writer is already writing. Since writer 1 is writing, writer 2 is not allowed to write and has to wait. Let's dive into the code. So in this function, we have two writers, which is writer 1 and writer 2. Writer 1 will call function a write function and then continues to write for 1 second. And then writer 2 will tries to write. Okay, it will wait for 0.1 second and then it tries to write. So we got thread to run this function simultaneously and start engine method to start and wait until this thread to finish. So let's see the output. Writing not allowed. Writer is waiting or reader are reading. Writing not allowed. Writer is writing or readers are reading. So why this happen? This is because the system check if a writer is already writing or a reader are reading. Since a writer is already writing, the second writer is not allowed to write. Almost there. Now let's go into the test case number 5. A reader is reading and a writer attempts to write. In this case, we have a reader who is reading from the file. When a writer tries to write, the system checks if any reader are reading or if a writer is already writing. Since there is a reader reading, the writer is not allowed to write and has to wait. Now let's see into the code. So in this test case with the writing function, we have two nested function, which is a reader will simulates a reader to reading for 1 second, and a writer will simulates waiting for 0.1 second and then tends to write. So we use thread to run these two functions simultaneously and then start and join method. So let's check the output. So reading not allowed, writer is writing. Writing not allowed, writer is writing or reader are reading. For the first output, which is reading not allowed, writer is writing, this is because the system check if a writer is writing. Since a reader is currently reading, the writer is not allowed to write. Then the second output, writing not allowed. writer is writing or readers are reading. This is because the system checked if a writer is writing or if reader are reading. Since a reader is currently reading, the writer is not allowed to write. Finally, we have a test case to check if the system can handle errors gracefully. In this scenario, we intentionally pass invalid arguments to the wait and signal functions to see how the system responds. The system should catch the error and handle it properly without crashing. By running these test scenarios, we can ensure that our solution to the reader-writer problem works correctly and meets all the requirements. It's important to thoroughly test our code to catch any potential issues before deploying it in a real world scenarios. So let's see the code. So here we got the try and accept block. So it is used to handle any exceptions that may occur. Inside the try block, we got the wait, none, and signal none function that are called with none argument, which is an invalid argument. If an exception occurs, it is called in the accept block. And the error message is printed using the print and the error. Okay. So actually, there is an error, which is the output here should be handled error argument must be a log, not none type. So this indicates that the system has caught the exception and handled it gracefully without crashing. So that's only from me.
Alright, as conclusion, the reader-writer's problem is a classic concurrent programming challenge requiring concurrent reads, exclusive writes, and preventing read-write conflicts. So our solution uses a combination of mutex logs and semaphores to control access, ensuring these key requirements are met. While the current solution is effective, potential improvements include prioritizing readers or writers, ensuring fairness in scheduling, exploring additional deadlock avoidance techniques, and optimizing performance based on the specific workload and requirements. Overall, the reader-writer's problem is a fundamental challenge, and the solution presented provides a robust way to address it in concurrent programming. Alright, thank you everyone for watching this video. Bye bye.